Well, Louisa had no slides, and I have quite a few slides. Hopefully, though, they will be interesting and entertaining. So I'm just going to get started. So the web is a little bit over 8,000 days old. Sometimes sounds like a lot and sometimes doesn't. So at this point, it reaches about a third of the people on our planet. I mean, needless to say, with mobile, this number just keeps going up really, really quickly. And as we know, I mean, it powers business and entertainment and learning and almost everything nowadays. I mean, it really has grown to take over our lives, and including all sorts of things that we'd never even remotely considered that we might want or need or find useful. But what exactly is the web for? And so I've been thinking about this for a little while now, and obviously there's no clear answers, but it's been kind of interesting kind of going back and thinking about where the web started and maybe what its value has become to us. And so one thing that I ran into last year, probably not too surprisingly, was a story from Steve Jobs. So this is from way back in 1980. So before the Macintosh was released, and Steve spoke at a little meetup in Palo Alto. It looked fairly low-key from the video that I was looking at. He showed up in a pair of jeans, and he had a checkered shirt, and he was late, and he was complaining about the traffic, and he kind of rushed up on stage and started kind of babbling away. But, you know, eventually he got quite philosophical, as he often does. And so this is what he said, and these are Steve's words pretty much verbatim from the video, which is available online. Thankfully, the Computer History Museum in Palo Alto has preserved it and has it available. So what he said was, in the early 70s, Scientific American did a study on the efficiency of locomotion. And so what they did is they looked at all sorts of animals, right? So for all sorts of different species, and birds and cats and dogs and goats and ultimately people. And what they were trying to figure out was how much energy it took for each animal to get, you know, from A to B at a given space, basically. How much energy they expended. And so they made a great big list. They studied all these animals, they made a big list, and they ranked them. And they published the list, and number one was the condor. Right, so it actually, took the least amount of energy to get from one spot to another, and it was quite above all the animals as well. I mean, it ranked quite highly. And then, man didn't do very well. It was kind of down. It came about a third of the way down the list, so far behind even, other kind of more mundane animals than man. And then somebody at Scientific American had this great idea. They decided to test man on a bicycle as kind of an extra kind of hybrid man, and so man on a bicycle just won. It just kind of blew everything else away, right? So it was twice as good as the condor and completely off the list in some ways compared to all these other animals and so on. And so what it showed is that man, as a tool maker, has the ability to create tools that amplify actual inherent abilities. And that's really one of the things that completely defines us as an animal in some ways. And so he said, that's exactly what we're doing here. And we referred to Apple, and he was talking about the development of one of the first personal computers, obviously being the Macintosh. And so he went on to explain that computers were just, one in a long line of tools that were created by man to amplify different abilities. So just as the bicycle amplified our ability to use our muscles and our brains and our tendons and everything to transport our bodies in different directions and navigate the world, then we had the tools of the Industrial Revolution, and he called them an amplification of human sweat. Which is a really kind of elegant way to put it. And then, of course, the computer, it amplifies, so many more things, right? So memory, problem solving, our ability to calculate, to project, to analyze, as Louisa was saying. I mean, we can analyze almost anything now. Not that it always does us very much good. So he realized also that the computer was really just the beginning. And you have to think back, this was 1980. I mean, the Macintosh didn't even really exist yet. But he was already thinking well into the future. And so what he said is there's something very special and historically different that takes place when you have one computer for one person rather than one for many. And again, I mean, this was at a time when one for one just didn't exist yet, really. So, as it happens, that particular statement is also true of the internet, right? The internet's ability to amplify knowledge, it started as a completely, it was academic and it was scientific, and that was really what it was for at the beginning. But the true potential of the internet, in some ways, it's almost yet to be realized, but we're seeing it, every day. We see it realized more and more. Is as a ubiquitously available tool, the more ubiquitous it becomes, the more people have it, the more we actually really start to realize what its value is. And there's this quote from Kevin Kelly, who's the chief editor of Wired, or at least I think he used to be. I'm not sure if he still is. And I think it's one of the best little quotes, I think, to encapsulate all of the stuff that we're building right now, right? Whether it's a mobile phone, whether it's the internet, no one really knows what a new invention will really be good for. The crucial question is what happens when everyone has one. And as we've seen with mobile, mobile was already so important at the beginning. Almost immediately we knew it was important, but it's changed so many times, it's evolved over the years, and its value, even now, almost keeps shifting, right? Our behaviors and how much it means to us. So when we connected a browser to the internet, we couldn't really have guessed what it was going to turn into. And similarly, when we connected that same internet and that same browser to this, these glowing rectangles that we carry around with us, we thought we were creating a smartphone. But in some ways, this isn't really a smartphone. And what it is it's a device to amplify our curiosity. It's yet another extension of amplifying man, amplifying our ideas, our curiosity. And so while that doesn't really explain what the web is good for, it kind of starts to clarify its value to us. I mean, the value is so much infinitely more immense than what we might have guessed at the very beginning. Being always connected, and the fact that it's an open platform, that it's accessible by anyone, it's just completely changed the way we live. If you even look at just, these are just random quotes. This is actually from a friend of ours, but this encapsulates a lot of people, the way they use the web right now on a mobile phone, right? At any moment, it's just like, oh, hold on, let me look that up. You've got the wealth, the sum of human knowledge is now in your pocket. Thanks to being always connected, always having the browser, always having the internet there. And this is a very kind of Western world kind of statement, but then you contrast it. This was from a study that Microsoft did of the use of mobile phones and the internet specifically in shantytown communities in parts of India. And, they spoke to all sorts of mostly young people who had different ways of using the internet, often on shared devices. Often they would actually trade microcredits on SIM cards so that they could each get little bits of time and allocate it. And whole little marketplaces had built up where some of the kids would actually buy the tariffs at slightly more from somebody else and then sell it back to somebody else. And it just turned into this whole economy. But the whole point is that, having access to the web, even though a lot of what they did was mostly download games and ringtones, but still, it was magic. The magic is in the palm of my hands. God knows what I would do without this. It had already completely changed their lives, and they weren't even yet using it for business, but they were at least using it for learning and for entertainment, and it was actually teaching them a lot about life already. And so, for 8,000 days, that's not too shabby, really. So, kind of look backwards a little bit, right? So how did we get here, right? So, to better understand it, we're going to take a step back, and we're actually going to talk about something a lot less romantic, which is plumbing. So almost all technological revolutions, there's a certain level of plumbing that actually needs to go in before things start to actually work, especially from the point of view of being useful to everyone, right? So as we know, plumbing, whether it's a web standard or whether it's actually things like the undersea cables that actually transport the internet, so to speak, it's a framework, it's a scaffold, it's this common level, basically, that we all have access to that allows us to innovate, right? Without it, actually, innovation is a lot harder, which is why standards and kind of common infrastructure are so important. And so obviously the rise of computers and the internet and the web, it's all linked to this type of plumbing. And really what it needs, there's the invention of it. And as we know, the invention is one thing. The implementation is another thing altogether. And then the implementation often has its messy parts, as we are often talking about when it comes to standards. I mean, the standards could have been implemented years ago, but their implementation, or they could have been spec'd years ago, but the implementation is actually where you start to realize, does this thing work? Does it suit our needs? Oh my gosh, we have to change it now, because actually it doesn't suit our needs. And then eventually, gradually, you get into market adoption, right? And it's only through these cycles that things actually start to move. And so if you look at some examples, look at hardware to start with, right? I mean, the entire span that we had to go through to get to where we are, you know, which is, and I don't think this is actually going to show up on the screen, but, you know, so we are all the way over here. And it started, you know, way at the beginning here around the mid-50s with the invention of transistorized computers. I mean, nothing, all of us being here in some ways could have happened without some of this stuff at the beginning. And you start to look through the progression, right? And you've got the microprocessor integrated into a single chip, which was one of the seminal things. And then, you know, more starting to think, okay, well, how is this going to impact technology? How fast is this going to move? And he predicts Moore's law, as we know. And then the evolution of all the different microprocessors, you know, from you got a first 64-bit supercomputer here, and the appearance of, you know, things that right now actually sound really modern, but I mean, resistive touchscreens were, you know, they were first kind of prototyped back in the 80s. You know, and you've got the progression of all the different processors, and then little mundane stuff like USB. I mean, whoever thinks of USB now as something really, really important? But it took 7 companies coming together to get USB and to actually get it implemented and out there. And then when you look at, you know, other aspects, you've got the same thing. So you have ARPANET way back that kind of started everything off. But then all these little micro moments, you know, including the first cellular network connection in Japan, followed very quickly by Finland, Norway, Sweden doing the same thing. TCP/IP was standardized. You had the first person-to-person SMS. Again, the invention of Bluetooth. There's another kind of mundane thing we don't really think about. And there again, 9 companies together, you know, pushing Bluetooth through. And then onwards to 3G, and then onwards to what we have right now. And so we had, you know, we had the hardware stack, we had the network, and then we have the web. And again, starting way at the very back with SGML, and little mundane things like the creation of the GIF and the, you know, the JPEG, the web debuting. There's another little kind of mundane thing being the ping. At least it feels that way now. But these were all kind of milestones, right? HTML 4.01, CSS, XHTML-MP, which now, of course, is basically gone, and then all the companies that spun out of this, right? So each layer creates new innovations, and then, of course, it spawns the need for more plumbing, right? So it's just kind of this continuous cycle. We don't realize what we really need until we've built something else, and then we realize there's a gap, and then we go and we build something else, which then spawns something else. And so, you know, if you were to kind of align all these things, you would see all these seminal moments of products being launched. But that could never have happened. You know, the Macintosh could never have happened without the microprocessor on a chip. And then, you know, the evolutions in displays that got to the point where we could have something that we could carry. The you know, evolution of battery power, all these various things that went from something big and heavy that sits on a desk to obviously what we have right now. And so this is actually a pretty clear cycle when you look back historically. This is Bill Buxton, the principal researcher at Microsoft, who loves to talk about kind of the evolution of technology from a historical point of view. And he says that it takes on average about 20 years for a technology to go from its first kind of demonstration, which often is, you know, the university laboratory or an R&D lab at a big company, all the way to maturity, which he measures as about a $1 billion industry. And obviously that would change over the years. But, you know, the mouse being a great example. It took about 30 years, really, from demonstration to maturity. And during this time, I mean, that 30 years can be actually quite treacherous because you never really know how it's going to go. You don't know what's going to kind of get stuck and then what will develop. And as we know, it's also, you know, the future isn't equally distributed, and neither is technology. You end up with potentially areas of the world that get, you know, stuck because technology doesn't evolve in the same way. So, you know, this is an example of Africa. I mean, some of these dates on here, like 2013, you're going to have this big pipe finally hitting certain parts of Africa in terms of finally connecting Africa to broadband. And for years, it was just tiny little bits, right? And which is why they lagged. But at the same time, because they lagged on broadband and connectivity, hard connectivity, wired connectivity, what you ended up with were other benefits, right? So it really just distributes kind of differently. They had mobile, not as distributed, obviously, as it is now, but they had it quite early on because it was the only way to access the web, because there were no hard landlines and so on. And so as a result, people had phones. The other thing they also didn't have was a really firm banking infrastructure. And so here again, we're talking about infrastructure, key things that allow people to innovate. So what did they do? They innovated on top of the phone and on top of the phone networks instead of integrating or innovating on top of traditional banking products. And they ended up with mobile banking years before, in some ways, any of us have had it. And most of Europe and North America is still trying to really integrate mobile banking the way that Africa's been doing for quite a while. So, you've got this kind of give and take. Lack of infrastructure can actually cause you sometimes to move ahead in other ways that you wouldn't expect. So, but getting kind of back to the web, the infrastructure of the web, so this framework that we're innovating on, it's actually, as we know, if you think back to when ARPANET started and when some of these standards developed, it's based on mental models that are now starting to feel a little bit old, right? And we're getting to this point where some of the mental models and some of the assumptions that we had of what the technology was going to be, how people was going to use it, and what we were going to need in terms of this plumbing and this infrastructure, maybe it will no longer apply very shortly. This is probably something that you might have seen already. It's Morgan Stanley's somewhat famous prediction that by somewhere around 2014, the amount of users on mobile will exceed the amount of users on desktop computers. Right. So all of a sudden, mobile will be the predominant use case, and so that brings us to the future. What will happen once that happens? So. I'm going to talk a little bit about the future, but at the same time, I think one of the things that's important to realize is that almost everything in this section actually exists today. All the stuff I'm about to talk about in this little bit, it exists today. A lot of it's actually available to purchase as consumer products, but it's just not quite mainstream yet, right? And it shows again that weird kind of progression of technology where it takes a long time for things to be adopted, and each technology is kind of at a different level as to how it's been adopted and geographically where it's distributed. So to start by talking a little bit about the future, so the first thing is we've got these 4 points basically that will kind of define how we have to design for the future, probably. And as Martin mentioned this morning, I mean, a lot of this stuff, the technology is heading in a certain direction, so it's become more and more plausible that this stuff is all going to happen. And as I've just mentioned as well, a lot of it already exists. So the first one is that contexts will be varied and they'll be unpredictable. And we're already seeing this right now, right? Martin was talking about CES this morning and all the different devices that were released. And it's just astounding the amount of technology that's being put out there. So even right now already, we feel there's a lot of diversity. Even in this room, there's probably 100 different devices from different people's hands. So it feels diverse. But the devices are still somewhat anchored in our past and in how we think about technology, but also culture and society. So let's take a quick look at some of these near future devices. And I'm not going to go through these in great detail, but just the idea is that basically there's going to be a lot of diversity, right? So this is just one out of many, many internet-enabled watches, for example. And each of these have different characteristics, right? But what's interesting is in this case, right, you have something very small, very personal, also very limited and constrained from an interaction design point of view. Different end of the spectrum, this is a piece of exercise equipment that is now connected to the web. So in some ways it has nothing to do with using the web at all, except that because you're bored on the exercise equipment, you might as well use some apps in the web. Totally different use cases here. You're using it in public, people might be around you, your hands might be sweaty, all the different things to do with how you might design for this. Vastly different from the watch we just saw. Television, some of these slides are actually about a year old, and a year ago this was actually considered new and interesting, whereas now it's almost every television you see in the stores seems to be connected to the internet in some way. But here as well, you have some things that, right now most people are still using remote controls to control these. But there are gesture-based televisions that I've already seen, some prototypes of in Asia, where you sit there and you do this to kind of scroll and pinch and you wave your arms around. And so completely different interactions than what we're used to. And then you have completely different contexts, right? So this is the new Tesla car with a gigantic touch screen kind of bolted onto the dashboard. And this is probably the least elegant version I've seen of trying to put a screen into a car. I mean, they've just pretty much anchored it there. And again, so this is kind of, you've got a big portable vehicle, but you have a very fixed screen while you're driving, all sorts of crazy interactions there. You've got airplanes, a lot of them are starting to put touch screens in, but they've always had touch screens, but these are good ones. These are capacitive displays. And some of them are actually putting in iPads that they're going to dock somehow. I mean, it's going to completely change the way we use an airplane, the way we enjoy being on an airplane. And then, of course, the airplane will have wireless access as well, right? So all of these were examples of cases where we've added a screen to something or we've added the internet to something. Then you also have other unpredictable contexts, which are just completely different. So this is a computer. It's about that big. It's basically like a little USB thumb drive, but it happens to also be a computer. And, it's got an ARM processor, it supports Wi-Fi, it's got Android and Ubuntu, and basically the idea is you plug it into another thing that has a screen, and all of a sudden there's your computer on the screen. So theoretically I could plug it into here, but I could also plug it into maybe the big display that was out there in the reception area. So you carry your computer with you really small, but then you borrow screens along the way. How that changes interactions is still kind of a little bit yet to be determined. You also have technologies that are going to kind of augment existing ones. So things like a virtual keyboard, which this works surprisingly well. And I've heard rumors that Google has patented the attachment of one of those to the Google Project glasses, so that you could, in theory, I suppose if you needed to type something, and since you can't use the glasses, obviously, to type, you could just hold your hand out and type onto your hand, right? So again, thinking about interactions, you have a device that 1 minute could be touch-based, the next minute could be voice-based, the next minute could be something else. And then, of course, there's a complete change of paradigm of what happens when the screen is no longer flat and hard, which is coming any day now as well. There's lots of prototypes like this of either completely flexible displays or, at the very least, displays that have been just built to be in a, so for example, you could put a display curved on the side of this glass here. So it would be hard, but it would be curved. But then others are completely flexible. And then finally, as we were mentioning, Project Glass, this is probably one of the more kind of futuristic things that everyone's always jumping on, because it has so many evocations of kind of science fiction and so on. But we really don't know how we're going to interact with this. What kind of data is going to go in? What kind of data is going to come out? So all of these contexts, they're very diverse, needless to say, but they still actually kind of fit the mental models we have from some of the original things, except maybe the glasses, but a lot of the other things are a screen kind of bolted onto something else, right? So we have the old thing, whatever it is, or some sort of a tool or device. We've added connectivity, we've added software, we've added a UI of some sort, and we have this smart hybrid thing. And that's a lot of what we're seeing lately, is just the addition of connectivity and smarts to things that before were not connected. But so what we're ending up with are a lot of products that kind of, we're not quite sure what they're going to be used for, right? I mean, the internet fridge is kind of an example like that, where opportunistically there's now a screen and connectivity on your fridge. You could use it for really interesting stuff, or you could use it for nothing at all, or somewhere in between. We don't really know what people will do with it. Now, if we go a little bit further into the future, though, hopefully we're going to get past this stage, and this won't really be the pattern we're dealing with going forward. So what we're going to end up with is a situation where everything is connected, and that's going to further change how we interact with things. So Moore's law is close to 50 years old now, as Martin was mentioning. We've got this huge evolution, right? I mean, this was the first kind of portable computer, the Osborne in 1982, and it was about this big, and you carried it around. And now, in 2007, you had the first generation iPhone, and the difference is staggering. The Osborne was 10 times the cost, 100 times the weight, 1/1000th of the memory. So we've really come a very long way, to the point where now it costs almost nothing to make something smart or connected. And just to give you an example, right, so this is one of the newer processors from ARM, and it uses a third of the energy of the normal 8 or 16-bit processors. So low energy is the first thing. Number two, low cost. It's only about 20 euro cents for this microprocessor. And then number three, it's only 2 millimeters in size. So you can imagine that this could go almost anywhere in some ways, and all of a sudden it's really cheap. The other change, not only is it cheaper and smaller, and it's also smarter. So whereas in the past we needed multiple chips to do different things inside the device that we were building, now the chips are a lot smarter. So they'll do the work of multiple chips. So one chip will give you so much more, and then it's already cheaper and it's already smaller. And then on top of that, a lot of them are being built with little units of functionality. So they almost, using the Lego analogy is probably not terribly bad, because, the job of the chip on the right is maybe to connect to a phone network. The one on the left is to connect to GPS. So they each have this little job that they do. So you could potentially turn something into, a mobile device very easily by simply using that chip over the other one. And you put all this together, and all of a sudden you can take almost any object and make it smart, make it connected, and you've got this new thing. And as we were talking about earlier, I mean, right now these new things, some of them are really strange, right? We don't really know if these are going to be any use to anybody. But still, from a design point of view and an innovation point of view, what's really neat is what you end up with is object-oriented hardware. This is a lovely phrase by Mike Kuniavsky, who wrote a book on smart devices and just recently left for a job at Xerox PARC. So, object-oriented hardware, you've got functionality that's been abstracted into silicon. So you've got these little building blocks, basically, of just functionality that you can just plug into bits and pieces. And on top of that, the last thing that will probably change things considerably is that right now, still one of the things that's a problem is you need a power source, right? The chip needs a power source of some description. But there's already quite a few prototypes of using ambient radio waves to power, especially these really small chips, right? And if you consider how small the chips are and how low power they're being built to be, you don't actually need very much power to power them. So the idea is that some of them could basically be self-powering, or at least self-powering for the lifetime of the device. If you think of really mundane devices like making a smart, well, maybe not this, but let's say if this were smart, right? If this had a chip in it, the lifespan might only need to be a few months from the shelf to the purchase to the disposal of it. And so potentially these could be self-powering for the periods of time you might need for really mundane things like that. So it's quite feasible that within a few years we'll start to see more and more of this kind of embedded webness. Everything will be embedded with a sliver of webness, of connectivity. And if you're wondering why I have this picture up here, this is basically an example of wearable technology. Her dress, if I recall correctly, I mean, you've got lots of little LEDs here, and the dress is responding to, I think it was tweets. But again, it's responding to data, basically. So you hook it up through an API to something, and it's connected, and it flashes and responds, right? And again, I mean, nothing is more, in some ways, mundane than a piece of clothing. Adding a connectivity to that is really quite something. So the more we look into the future and the more invisible this kind of webness becomes, the more we kind of get to the next bit, which is we're more likely to be interacting with things just in time rather than just in case. So we already know that mobile has shifted web behavior quite a bit, right? So we can use the web almost anywhere at any place. We're starting to use it in places we never would have expected, things like airplanes. But right now, it's still quite implicit. This is probably the best way to show it, is that a few years ago, we still had the behavior of we would go to the computer, we would go to a different room, sit down, go to the computer, and use the internet. Okay, so now that's kind of gone away. Now the internet is in our pocket all the time, so we no longer have to go anywhere to use it. But we still actually have to, there's still a lot of steps involved, you know? So you unlock the device, you find the browser, you type the URL, or you find the app and you open the app and then you use the app. There's still an awful lot of steps, and it's still very much about intent of I am going to go do this, right? So as a result, we've built experiences accordingly, and this is mostly to do with the web at this point. Websites are just this giant kind of mass of kind of just-in-case data. We don't know who's coming. We don't know what they're going to need. We don't know when they're going to come, what context this will be in, what they'll be trying to do. So we fill them with everything we can possibly think of. That's kind of the giant touch point of your company with the web, right? So just in case, we fill it with this stuff. And so as we know, websites are now very full of stuff. And because of mobile and because of apps, this has kind of improved a little bit because we now have the ability to create these little encapsulated interactions with applications that people download, whether it's web-based or native. Doesn't matter so much. It's still the fact that it's kind of a thing that you do in advance, right? So you know you're coming to Helsinki, so you will download the app to find out about the transit system. There's still an awful lot of planning that is maybe a little bit too much planning for what's coming next. And when it comes right down to it, it's not that we really want these. I mean, none of us want these apps. We want the possibility space of the app. We want the stuff that the app can enable us to do, whether it's find our way around, whether it's purchase something slightly more cheaply, whether it's interact with our friends. It's the possibility space that's important. When it comes right down to it, owning the app, managing the app on our phone isn't really what we need. And so if we consider that it's far more likely in the future that everything will be connected in some way to the internet, that a lot more devices will be smart, it starts to sound even weirder for us to be in advance, kind of planning ahead for all these interactions, right? What we need more is some sort of a model that enables more opportunistic interactions, where in some ways, if this were potentially smart, if this were potentially smart, there could be 1,000 smart objects in this room. Are you going to plan ahead, get a URL, download an app, manage for all of these things? I mean, that's completely absurd. You actually want just the opposite. You want completely throwaway, opportunistic, something tells you that this is smart somehow. It notifies you. If you want to interact with it, you can. You don't download the app. You don't save it to your phone. You don't save it to memory. I mean, you're never going to use it again. This is just kind of a quick little just-in-time thing. And these will probably become more and more common because we'll be interacting with stuff that's kind of all around us. And there will be certain things that we want to hold on to data about, and then other things where it's the last thing we want to do. So a person who talks about this quite a bit is Scott Jensen, who used to be at Apple and then Google and then Frog Design and is now with a startup in California. But he talks about a world where our devices load applications opportunistically as we need them in real time. These are completely throwaway. And the technological model for this could still be web pages. I mean, there's no reason that we need a different platform for this. But these would be web pages with advanced technology and functionality, and that can be accessed seamlessly from remote or local networks. And that's the other thing, too, is remote or local. I mean, we always talk about things being connected to the cloud, but it doesn't always have to be, right? There's actually no reason that devices couldn't communicate with each other and that some data could actually be local to this room. So it's the idea that you very opportunistically and spontaneously communicate with whatever data you need. So, I mean, does this mean that the websites as we know them will go away? And the answer is probably not. I mean, I'm not suggesting that websites will disappear, but they will probably be just one of many interfaces that we use to interact with a service. Right now, a lot of our interactions with services from a digital perspective are entirely with the web. And Martin showed the GlowCap service this morning, which was kind of a nice example. It's a very nice example, actually, in the sense that most of the service actually revolves around the bottle itself. Sure, you could have put a screen on there. You could have put a tiny little e-paper display that doesn't cost very much, or maybe in the future you could put a flexible AMOLED display which would cost an awful lot more. But why, right? I mean, the only interaction you need is to know that the person's opened the bottle. And from an output point of view, sure, the person could sit there and look at the bottle, and there could be a little tiny screen, and they could look at something saying, you've forgotten to take your medication. But again, why? All you need to do is for the light to flash and for it to buzz, and you've got the same reminder. So it's the idea that, data's going in terms of actual sensors gathering up information. Data's coming out. Who cares if there's a screen, right? I mean, the fact that we can put a screen on there doesn't mean that we need to. And actually what happens is that then you interact with the data in the best spot you can. So the best spot to interact with the container is actually with the container in terms of it buzzing or flashing at you. But when you want to find out, how often did you take the medication and how well are you doing, then you go to your website, you go to your app, and that's where that more complex data is interacted with. Another recent example, it just came out a few days ago, very much following the same model, right, is the Happy Fork. And there again, the idea is that the fork will help you modify your behavior. In this case, it vibrates if you're eating too fast, which must be really, really annoying. But once again, I mean, the bulk of the data is you're interacting with an app to actually get kind of the analysis of the data. But day to day, there's no screen, there's no user interface, there's no buttons. The only interaction you really have is it vibrating. And so, you start to see how what you end up with is interfaces that are kind of starting to disappear, basically, right? The interfaces are wherever you need them to be, and sometimes you just don't need an interface. It's the last thing you actually need, or you need a different interface. I mean, a fork is actually an interface when it comes right down to it, but it's one that you don't need instructions for. So when you kind of move this to the very end here, what you end up with is that if all the contexts are different, if everything is connected, if the interactions are a lot more kind of just in time, then the content will actually probably need to flow much more freely than it does right now. So often we talk about responsive design as being kind of the way that content flows and is now available to flow into all these different containers. But responsive design is really kind of just the beginning, right? So if we can envision, again, this ecosystem of varied contexts and everything connected and so on, then it becomes a lot easier to start to think about things that are just completely unlike what we've experienced before, and to also realize that responsive design probably won't help us with this. We actually need to go even further. And so we need to get our content to actually go almost anywhere. So for this very last little bit, I'm going to talk about kind of plumbing again, but what plumbing will we need in the future? Maybe. So I've got a couple kind of examples of reimagining plumbing. Now, these are just ideas, and these mostly relate to the browser and the web platform, right? So because there's all sorts of stuff we might need, but because this is mostly a discussion about the web, I'm going to talk about the browser and the web platform itself. And seeing as I'm in a JavaScript and HTML5 type conference, some of these ideas may seem a little bit strange. So bear with me. So we already actually have a lot of infrastructure, and if we think back to how the browser was built, there's already a lot built into the web platform that has actually made it insanely easy for users to use, and we just don't really always think about it, right? And a lot of it is scaffolding, similar to what we had talked about in the early days of scaffolding the network infrastructure and so on. And a lot of these things now seem completely mundane. So one is, form elements. These were built super early on, and they've guaranteed that we've got this common interface to do very common input and output type of interactions. Others were to do with productivity. And when you look at the browser itself, I mean, there's so many of them, right? And they all appeared at different times. The URL bar being one of them, shortcuts, bookmarks, the favicon. And if you look historically, you realize, I mean, they don't all come at once. Even things like the back button was added in 1993. I mean, people were already using the browser, and then they realized, oh gosh, this isn't going to work without some sort of way of getting back. So we've gradually enhanced the browser in ways that we kind of sometimes now forget. But we now have all these little tools built in. And the ultimate goal is to make it easier for users, but also to make it easier for ourselves. ourselves so that we're not having to kind of custom build all this stuff every time. When you look at mobile, we added access key navigation, which now is potentially a little bit less relevant, but just showing things that were added gradually in response to a need. So the other thing that also happened was there were also changes, right? So the URI schemes for telephone and for SMS were a nice thing that was added in response to change. One of the other ones that we kind of have almost forgotten about now is how hard it was at the beginning to figure out how to navigate the browser. When we finally got WebKit and proper HTML onto a small screen, is the whole kind of conceptual model of, okay, well, what do we do? Do we show the big screen? And then how do people figure out where they are? And then how do you get back and forth? And do you do it visually or not? And even now, we're still experimenting with the best way to do this. And then more recently, you've got these little reader modes that have appeared. And these are almost kind of our fault, quite frankly. I mean, the websites can be really heavy. And so one of the easiest things to do as a user, if you want to get rid of all the noise and everything, is just turn on your reader mode or load something into Flipboard, and all of a sudden you've gotten rid of all the noise, right? So these are things that browser manufacturers have been adding to make people's lives better, but also in response to kind of it's almost a bit of a crisis, right? What do we do with all this content on this small screen? Well, one thing we can do is let people see less of it. Other response to a crisis is all the proxy browsers. Obviously, Opera Mini's been around for a long time, but the idea that people are consuming a lot of bandwidth, websites are still very heavy. Until all this sorts itself out, a proxy browser that optimizes on the server is not a bad way to do it. On-the-fly user agent switching is another one, not a very popular one, but again, simply a response to change and stress in kind of growing pains, right? So everybody knows that some people build websites just for the iPhone, and so what do? You put user agent spoofing right in the browser so a person can say, oh, today I'll just pretend I'm an iPad so I can see this website, and then tomorrow I'll pretend I'm something else. And obviously, you have all the stuff that's being built into HTML5 that's also baking in common functionality. And the whole point of all of this is basically to offload aspects of behavior to the platform itself, right? So things like the new HTML5 form elements. I mean, the amount of time we used to spend, and still do in some ways because it's not yet fully supported, building all this stuff in, right? Building placeholders in, building little calendars, building little color pickers. If all of these were all in there, then presumably we could all focus on building the rest of the website, the part that the business relies on, right? I mean, it's crazy that we spend sometimes a lot of time talking about building a calendar when in fact the business isn't the calendar, the business is everything else, and there's still a lot of stuff that we need. The HTML5 notifications API is another really nice example of offloading little common notifications to the platform itself so that you don't have to actually add them back in using JavaScript and add them back in using the site. So the end result is what you end up with is components that are native and that are intelligent, they're responsive, they're platform appropriate, which is really important if you think going forward of all the different devices we're going to have. And they're adaptable, again, because they've been built in at the native level, right? And we're seeing this with all the form elements and so on. And of course, you do lose control, right? So, I mean, if you use an HTML5 input type and you use the native calendar, you've lost the control in terms of controlling the calendar, but at the same time, you've gained back all this other time to focus on the rest of the app that you're building. And this loss of control is usually okay because the alternative, for example, is having to write all this JavaScript and then having to maintain it, having to do all this stuff basically to create a component that you could be offloading to the browser. And Alex Russo, who works for Google, has this really nice way of putting it. Is everything you add to the page is something you're taking away from the latency profile of that page. Everything you add just as infrastructure to make things work. All of these things have a cost. And so right now, with the shift in devices and the coming shift of more and more devices, more and more interaction models, we can imagine that we will be spending still an awful lot of time creating all this extra infrastructure to make things work because it's not yet in the platform. So what if we thought into the future a little bit of what we could do to actually take this approach of baking functionality in a little bit further? So I've got a couple ideas here. Some of them are a little bit strange, potentially, and some of them are kind of potentially disruptive in terms of how we currently think about websites. But maybe it's just something to get you thinking. So I'm just going to cover 4 problems, and then I'm almost at the end. So problem number 1, I'm starting with something really, really mundane, right? Problem number 1, back to top. Right, so websites are now very long, often on small screens. You get to the very bottom, you need to get back to the top. For some reason, we still don't have a common way of doing this, so we're all adding back to top links. But then, of course, what is top and what is bottom, right? Because the screen is now, there's different screens, you're building responsive websites. Well, maybe you need the back to top links on a big, long strip of a site, but you don't need it when you get to the larger screen. So maybe you add them in dynamically. Maybe you write some JavaScript to say, OK, I'm going to calculate the length of the screen, and then I'm going to decide where to put the back-to-top links. And all of this stuff is an awful lot of extra work for something that the browser could just do. This is an example of the QQ browser out of China, and I've kind of darkened these just to show them a bit better. But basically, they have a control it's superimposed onto the screen. It's transparent. At any point, you can just tap it, and it jumps you up or down. You can also customize it, so you can turn it off if you don't like it. And I think you can even customize how much it jumps, so you can either jump all the way down, or in little increments. And this seems really, really mundane, but if you think about the fact that we're going to have all these different ways of interacting with devices, in some ways, this should almost be a behavior that's built into any browser. And if you think browser, I mean, any device that's going to interact with the web and will have a screen will need a browser. But you don't know what these devices will be yet. So this is one potential type of thing that we might want to think about in terms of enhancing the browsers for basically to stop us from having to do all this extra stuff and be able to focus on the site itself. The next one is social media, right? So social media is obviously an integral thing now. So how do we add social media to websites now? Well, at the moment, we've got all these little third-party JavaScript things that we plug in. A lot of them are, they cause a lot of HTTP requests. Very few of them are responsive. And some of them are little like buttons, which is fine, but then others are actual little widgets. Those are even harder because a lot of times they've got an inline frame or some other way of doing some sort of scrolling. And the more popular social media gets, the more of these you need, right? So you end up with a lot of sites that kind of look like this, where you've got stuff dotted all around, creates a lot of noise. So we know social media is not going to go away, right? I mean, about 70% of the worldwide population uses social media now. They're probably here to stay. All this social stuff, right now we're almost treating it like content. It's kind of part of our templates, but it's kind of part of our content. It's not really content. It's not really Chrome either. It's almost utilities, right? It's almost something that should actually be kind of baked in. So maybe it actually is plumbing. And Pew Internet, which does a lot of research about how people use technology, they like to say mobile is the needle and social is the thread. And I think it's a really nice way of looking at it, because in some ways it should be a thread that runs through everything, right? But in that case, is it our job as developers to have it dotted through everywhere, or is it something that's just baked into the browser itself, right? Is the browser basically the API that we target? And so this is just a really rudimentary example, but the idea is that rather than all of us dotting all these things around our websites, is that basically it's a browser component that no one has to worry about. It's always there, but you can potentially target it through an API, right? And it gives more power to the user on the one hand, because also, how many times have you been to a site where they've got little social media thingies for sites that you don't use, but you'd like them to have one for, the site that you do use? We're creating all this noise on our websites. It would be nice if users could just choose what services they interact with, but also have it basically where it doesn't matter if you were using Google Glasses and you were using it with voice, or if you were using your TV. Basically, the social layer would be baked in right into the browser. Number 3, navigation. This is probably the wackiest out of all of them. So there's going to be lots of devices, lots of shapes and sizes. And navigation, let's face it, is a bit of a pain, right? So responsive design, one of the big challenges, one of the things people are always fighting with is navigation. Where do you put it? How do you collapse it? Where do you put it so people know how to find it, so that it opens and closes gracefully, so that it works every single time, so that you can fill it with the right amount of stuff, so that people understand what they're looking at, so the right relationships are there. What would happen if we offloaded top-level navigation to the browser itself? right? So completely content-first approach. The browser is rendering content, the navigation is considered a level above, and the browser handles it. So here's an example. Here's Wired. They have 56 items in their top navigation. So this is just random site, but at the same time a good example of, okay, how do you fit all this in on all the different devices if you're thinking of the whole spectrum of devices we might need to interact with. So here's a quick visual example, and then I'm going to explain it, right? So right now, this probably doesn't look very different from anything we've seen on a responsive site. You've got this thing that slides open, you've got this menu. It's like, okay, fine. Yeah, what are you talking about? This looks like the Facebook site, right? So just imagine it a little bit differently. Right, so this little menu button, instead of, it is still a little menu button in HTML, but basically what it's doing is it's calling a native component, right? So you've got some little piece of, some little attribute that says, okay, please trigger the native component if it's there. If it's not there, then it degrades back to HTML, right? And underneath, though, you still have the regular markup, right? So the idea is it would be something that would be degradable, but that would have a native trigger, basically. Similar in some ways to the input types, right, in HTML5. So you say input type date, and you get a calendar widget. Well, we would say input type maybe, menu. Obviously not menu, but something like that. And so basically it triggers a native component. And the idea is that the component is native to the device, but as a result, the performance, the responsiveness, all of that has actually been handled. It's been offloaded to the browser itself. So you get GPU acceleration, you get device-appropriate transitions, if transitions are warranted. Basically, you get device-appropriate everything because it's provided by the browser, and it's the browser's job to decide what is the best thing to provide, right? So the user gets the best, most appropriate experience. And you have to remember, again, maybe the browser isn't even visual at all, right? Maybe there is no screen. Maybe you're just interacting with data. You get the most appropriate way of doing that as well because the navigation's been offloaded. So again, if there's scrolling, it's got native performance there. You can potentially tie it into search. I mean, that would be a really nice way to do it. So you offload some of that as well, all the predictive text and stuff that we try to add into our sites. Menus could, in theory, be as long as they need to be, of course, within reason. And all the stuff like, progressive disclosure and drilling down, all managed by the platform. And then, basic styling of the component would be available. So it wouldn't be this thing that would look like Opera or look like Firefox. You could have some basic theming, basically. And this is kind of, in some ways, where it makes the most sense, because it really wouldn't matter what device you're on, right? It could, like I said, it could even be a voice interaction. The most appropriate interaction, the most appropriate menu for voice is nothing like the most appropriate menu for a TV. The question is, are we going to all have to build all these different variants or figure out how to take a responsive version and make it responsive for all these variants, or do we maybe let the browser handle it? And when you start to look at some of the new CSS specs, like the new CSS pagination, where again, they're offloading things to the browser that traditionally we always would do ourselves. We would build in pagination, right? So we're starting to offload that. And the web components that are being discussed, which would also kind of encapsulate behavior into components, you could start to see how this might make sense. Very last example, images, which is always a really popular subject. So as we know, there's a lot of problems with images when you're dealing with all these different devices. An image that's suitable for one device isn't always suitable for another. It might be too big, it might be the wrong format. You might not be able to properly read it, even if it is in the right format or the right size. There's the issue of pixel density, there's the issue of bandwidth, which, as somebody mentioned already today, is going to be a really hard one to crack because it's, the difference between what if they're on Wi-Fi, but the Wi-Fi isn't any good, right? So there's all these potential things we're trying to measure to get just the right image for everybody. But what we're left with at the moment in terms of how we're going to deal with this is either the proposed picture element or the what working groups version, which is still pretty binary. I mean, it's like, if it's this screen, put this image. If it's that screen, put that image. It feels as if we're actually going to need more than this. Going forward, it just doesn't feel like this is going to work long term. So maybe what might be useful is a smarter image element. And obviously this is, completely imaginary, but at the same time, there's some precedent for this. This is the precedent I want to quickly talk about. Why not a natively adaptive, basically media container format, right? So we don't think of it as an image anymore, because if we think of it as image, then we're stuck in the ideas, or mental models of images. So we think of it as a media container, because increasingly also it's not just replacing a ping with another ping. You might replace a ping with SVG or with other things, right? With Canvas, for that matter, right? So back in 2000, Apple had something called the wired media container format. It was built into QuickTime. And what it basically was is you would download this basically highly compressed initial download. It was about anywhere from 2 to 20 kilobytes. I mean, it would vary, obviously, but small, right? So small. You would have a poster image, so you would have a preview version. So some sort of an idea of what it was you were going to get. And inside, you could package, as a developer, you could basically specify all this different stuff that would be in there. You could have a low res and a high res and a whatnot, different versions, different formats. And it had built-in content negotiation. And it was actually back then, because it was mostly used for video, because it was for QuickTime, it was based on connection speed. So Apple was actually, built in, it would decide what was the best piece of video to serve to you. But you could imagine extending this, basically, to the idea of images. And, and it also had this out-of-the-box native component that could prompt you. So this is another thing that often comes up with the responsive image problem, is maybe we're overthinking it. Maybe we need to ask the user to choose, right? Maybe the user needs to, at some point, have the option to say, I actually want the high-res image today, even though I'm on 3G, because this image is really important to me right now. So it actually had that as a native component, some sort of dialogue where you could let the user say, actually, no, sorry, you've given me the one I don't want, or please give me this one. So unfortunately, there's no links to point to this, because it's from 2000, and as we know, the web sometimes disappears things, right? So, and plus this was Apple, so Apple never leaves stuff kicking around if they no longer produce it. But this type of approach might work really well as a container that would contain all sorts of stuff and that would have the smarts built in to know what to do with it. And then when you think about all the other stuff that's being added to CSS right now, like the CSS exclusions, all the different pixel shaders, and all the different blend modes that are being added by Adobe, you could start to imagine that you could actually take a container, basically put the ingredients that you would need for the different experiences, and let the browser layer make some modifications, and you could end up with truly adaptive media and/or images. So these are just ideas, however. The reality is we have absolutely no idea what's going to happen next. When I was a kid, we kept telling me that we would have jetpacks by now, and we clearly don't have those. And to leave you with one last thought from Don Norman. Don Norman, the very famous interaction designer, made a really interesting observation quite a few years ago, that technological revolutions have a lot of interesting properties. One is we tend to overestimate the immediate impact, and then we underestimate the long-term impact. But the second is that we place a lot of emphasis on the technology itself, when it's really the social impact and the cultural change that will be most dramatic. And as many of us have talked about already today, the social and cultural change is the hard part, right? I mean, how do we build this stuff? How do we build it with the companies that we have, with the skill sets that we have? How do we change the browser potentially from what it has been the last 10 years to what it needs to be? And how do we decide what it needs to be? Who's going to decide? Is it going to be the W3C, the What Working Group? The social stuff is often the stuff that we get stuck on. The technology is all there. There's a lot of technology just waiting. But we need to all decide what our priorities are and hopefully figure it all out. So I'll leave you with a quote by Bruce Sterling: "The future is a process, not a destination." Thank you.
Great. A couple of things. I'm going to be getting a happy fork, and I think a lot of other people will as well, because there were a lot of tweets about it.
Everybody was excited about happy fork.
That's like the best thing ever. And the second thing, I could listen to all day. So please come back. So a wonderful multidimensional presentation. Thank you. Thanks a lot.
I don't know if we have time for questions.
We do have time for a few questions. So Andrew, please. Jakob, could you please bring the mic?
That was very, very good and very, very interesting. I hadn't come across the QuickTime package format for the different different types of images that you could deliver, and I'm just wondering whether that had any thought that went into it around art direction.
That's a good question. Is Brian back there? Because Brian, for about 5 years, did nothing but QuickTime work, and he worked with Apple, not at Apple, and so he knows this stuff far too well. Was there any art direction built into the QuickTime package media format? Like, could you? Sorry? He said you manage the art direction through scripting. So I guess, I mean, you could. Yeah, that was the one thing I forgot to mention, actually. Not only could you put stuff in there, but then you can also apply some scripting to decide what it was going to do at some point. So yes and no, I guess.
Okay, thanks.
All right. Anyone else? So if no more questions right now, are you going to be sticking with us at the after party? And
we'll definitely be at the party for a bit.
All right.
And,
sounds great. So thank you again, Stephanie.
Sure.
This was wonderful. All right. So we're about 20 minutes behind schedule, but let's continue at 5 minutes past 4. So a 20-minute break here, and we'll have our 2 last sessions after that. Thank you.